seriously. Types of plastics, we have two. One,
Thermo-softening plastics.
and then and
Thermosetting
thermosetting plastics.
plastic.
Thank you very much. Those are the two types of plastics we have. Now, some softening. You hear the word softening. What is softening plastics?
These are plastics that soften or melt when heated.
So when you melt that plastic, an example is your plastic basin at home, a plastic cup at home. Once you melt it, you can mold it into another shape. That is what we call thermo softening plastics. You can soften it by heat and change it to another state. What is thermosetting plastics? Thermosetting. Sonia. Sonia. Thermosets. What are thermosets or thermosetting plastics? If you have had some softening, those ones you can heat. After heating, you can change it to another shape. What about thermosets? The opposite of softening is thermosets. What's that?
The hardening.
Plastics that
You heat and
They do what?
These are plastics that do not soften or melt when heating.
Actually, when you do that, you are just breaking them. The moment you heat them, they will never come back to that state. They will go to maybe ash, something of the kind. Okay? An example is the sockets we use at home. Do you see those sockets?
yes.
Yeah, those ones where you put your extension cable or you put the percolator while boiling water. Those ones, once they have set in that shape. If you put them on fire, you'll never get them back. They'll just disappear. Okay? Those are some of it we have. So we looked at ways of confirming within gas. What is you looked at three methods, but I want only two. How do you know this is within gas? What do you use for testing within gas? You have got ethylene gas in the tin. You want to know that this is ethylene gas. What do you use? Huh? Did you look at something called bromine water?
Yes.
Did you look at something called potassium permanganate?
yes.
Yes.
So somebody describe for me what happens, because those are the common questions they ask, and they want some equations of reaction. When you use bromine water, what do you form?
Saturated solution.
Bromine water. They say bromine water is always brown in color or reddish brown. When you add ethylene gas to that bromine water, what happens? The bromine water becomes what? Decolorized, isn't it?
Yes.
Due to the
Yes.
formation of 1,2-dibromo ethene plus bromine, what do you get? it becomes 1,2 dibromo. And that is the only test you must know, by the way, for you to know the degree of unsaturated compounds. That's what should be known. Because when you mix ethene in bromine water, this is what we saw some time ago here. When ethene gas, look at my screen here. When ethene gas is bubbled through bromine water changes from reddish brown to colorless, i.e., bromine water is decolorized or the reddish brown color of bromine is discharged. So when that color goes away, it is because of the formation of 1,2 dibromoethane, isn't it? Yes? Isn't it what we say?
Yes, teacher.
Yes.
So you must read, otherwise. Let me get a video here. I promised you that video. Bromine water. So watch your screen. I'll be explaining. I don't know if it is listening. What is this word here? Testing for what?
Testing.
For alkenes, isn't it?
Alkenes.
Using bromine water. The first alkene is ethene. Okay. We told you that bromine water, what alkenes have is the double bond, isn't it? Now, if
Yes.
you want to test for that thing, if it has the double bond, we use this bromine water. And this is what's going to happen. In the discussions we had, we saw that carbon of alkenes have double bond, isn't it?
Yes.
And this is what they are meaning here. That in the previous discussion, it was seen that carbon bonds with another carbon with a double bond, and that one gives us the name of alkenes. Possession of that double bond is the situation that causes us to test for a degree of unsaturation of that element. So you see what I was telling you, that these single bond have ability or have the power to attract each other close to this, but it is not when you put it at 90 degrees, no. These ones, the double bond has ability of repelling. It has ability of repelling the single bond. So that's why this gap is far. This gap here, these two gaps are larger than these ones. So that's the main cause there. But now, if bromine comes in, it's going to break one of these bonds, and then these things will just rotate. This what is going to happen? You have seen what has happened. That the double bond breaks off. Bromine and bromine also break off from their bromine Br2. They form simple molecules. So what happens is they come and join this. Now, since it is brown in color, or reddish brown or yellow, the final color will turn to colorless because it has combined with an ethene gas, and it's going to give us an alkane. Now, do you see this is a structure of what? An alkane, isn't it? It is no longer an alkene because the double bond has disappeared. So that is addition reaction. So what happens? This alkene is bonded to few hydrogen atoms. It is supposed to have 4, but because of the position of the double bond, it is now in position. It is now like this. But if this bond is broken, this thing will rotate the way we shall see in front there. So alkanes are saturated. You see the difference between this and this. Have you seen the difference? Yes?
Yes, teacher.
This one has a double bond. This one has single bonds because the double bond has been replaced by the bromine. So this one is not an alkane anymore. It is the alkane. So it is supposed to be like that. So testing for alkenes using bromine water, chemical test, and that's what happens. All of them, alkenes are colorless, most of them. So ethene gas, we shall also see what happens when you add ethene gas. What is the name of that compound? Yes? What's the name of that compound?
Hexane.
It is?
Hexane.
Hexane. 1, 2, 3, 4, 5, 6. Hexane. Thank you very much. So that is the structure of hexane. All those molecules will react to go back to that normal state of alkenes, sorry. So that is what we form there. What about that? What about that one? Huh? What about this one? Who can give me the name of this compound here? Hey, time is going, time is going. What's the name of that compound? Yes, Letitia.
It's hexene.
Hexene, isn't it?
Yeah.
If you use 1, 2, 3, what's the name? That is, the hexene is correct, but now I want a more modernized name because we have learned how to name these compounds. It is called hex what? Hex 1-ene, isn't it? Yes? The name is hex what? Hex 1-ene, isn't it? So now if we want to break this and take it back to alkanes, we use bromine water. Bromine water just attaches itself there, and what happens is this. So bromine is the atomic molecule, and that's what happens, and that's how it breaks. So the here, which color is this?
Light brown.
Light brown. Light brown. Okay, that's take an example. That is our bromine water. Okay, so what happens to it is this: